All right. So again, you already got this back if you were here Thursday. I graded them all and gave them all back to you. So let's just quick run through it. Your first question was just a very, very basic quadratic trinomial. You should not be on your Chromebooks right now. They should be closed. You should have your snapshots out and you should be writing things down. This one is just basic, just like, again, it's a quadratic. There's no GCF, there's no fancy stuff. We just put in our X's and we know that there are two minuses, and then we think about numbers that make 18. And of course we would want 9 and 2 because they also add to make the negative 11. So number one, done. The second one is just a very, very it looks intimidating, like if you don't know what you're doing, but if you recognize it for what it is, it's a very basic difference of cubes. So this will be the thing you want to work on throughout the week, is your identification and making that really good page of notes that has, you know, what does this look like and what does this type look like? So we know it's cubes because we just see that it is. I mean, for goodness sake. So what's the A value on this one? And what's the B value? Just 5. Yeah, and you don't need to put negative. No, you're fine. And remember that the negative gets gobbled up in the formula, so it's all good. So then we just have to recognize that it's a short set, long set problem. So we build our short set and we build our long set. And remember that you're in an environment where you get to have notes. And so not having that formula would be pretty silly, right? I mean, I don't think it's that hard to memorize, but just to be safe. So it's, remember, the first one is A minus B. So 7x minus 5. And then the second one will be the A squared plus AB. So that's 49x squared plus, multiply those together, 35x plus B squared, which is 25. And that is that. All right, that's just a bottom of the barrel, run of the mill difference of cubes. Good. The third problem, I had some fear on Thursday when someone asked for the factors of 144. That's when I knew that some trouble was happening. This is not a trial and error factoring problem. Your job is to recognize that this is a difference of squares. That is on you to recognize that. So the square root of x squared is x, the square root of 144 is 12, and that is a minus sign. So we are good to proceed. No trial and error. It's just x plus 12, x minus 12, done. Any questions on the top row? Hey, the second row starts with a grouping problem. However, there's a little bit more to it than just grouping, and you better get used to this. No, never mind. I'm thinking of something else. This is just a grouping problem. What's my cue for my notes? Like, what's my visual identifier that it's grouping? How do I know? It's four. Good. And the 4 terms are just going to stick out. So make sure you recognize, okay, there's 1, 2, 3, 4 terms. It's time to go. Draw the wall. What's the GCF of this left half? Nice job, Hugo. I can get out a 2 and I can get out an x squared. And what does that leave behind? Perfect. And then what do I do next? Drop down your negative sign or your minus sign. And what do you? 7 is what you can get out. And then we rebuild. Yeah, and we change that sign because we pulled out a negative. And we're not done, right? We do hope, though, and recognize that these two things are the same. If they're not, just go back and try to figure out why they're not. Something went wrong someplace. At this point, I'm going to make sure any 4 term is groupable. No trick questions. And so if it's 4 terms, this ought to work. And with those being the same, then they'll make up the first factor. So 3x plus 8 is the first factor. And then the red things build the second factor, 2x squared minus 7. And all we're going to want to remember to look for is always check this quadratic factor to see if maybe it's a difference of squares, which of course, in this case, it's not. So this is the final answer here. Done, done, done. What is the 5th problem? What kind is that? It's a lookalike, right? And what's my visual cue for that? Right. Just remember the pattern is even number, half as much, none. Even, half, none. If you can make the problem look like that, it's a lookalike, right? And so we just treat it like a normal quadratic. We call it a look-alike because it looks like a quadratic, right? That's where it gets its name from. And then we just put half of it here, half of it here. What are my signs going to be? Plus and minus for sure, because of the minus on the 16 in the back. And the numbers? 16. So I want a plus with the 16 and a minus with the 1. Done? No. No. This one is a, what's it called again? Well, okay, it's a difference of something. It's a difference of squares, right? So we're going to leave the x squared plus 16 alone because it's got a plus sign. I can't do squares with pluses. And then the yellow underlined one breaks into x plus 1 times x minus 1. And that now is done. And this next problem marks the halfway point. And I talked very specifically with you guys as a class about this on Thursday. And it was sort of after I had already graded a couple and I realized that I need to do a better job of repeating myself. You do not factor this. You pull out a negative first, and then you rewrite the problem as what it is after you pull out the negative. I'm not asking you nicely that I think maybe you should do that. You need to do that. And that's going to become a big thing starting today. The practice quiz is loaded with GCFs. And when you pull a GCF, you are essentially rewriting the problem. And I need to see it, and you need to see it. And then what's left over in parentheses is the math problem now that you factor. What is in parentheses? What's that called? What is this called? It's a sum of cubes. Perfect. So I recognize it as an AB problem. What is A? What is B? If you by some chance have not figured out the importance of writing down A and B, you really should probably get on that because it's hugely, massively important, because then it gives you all the pieces you need to plug into your short set, long set. So while I pour my coffee, what's our short set going to be? Yeah, or in this case, x plus 1. And then what's our long set going to be? Yeah, remember, nice job. Remember that the long set will get the minus in the middle if we didn't use the minus in the front and the short set. So since we did not use the minus here, then this will be a squared minus ab plus b squared, like that. Notice the red negative, it doesn't go away. It's part of the answer and it has to stay. So you pull out whatever you need to pull out, rebuild the problem, and then work it from there. Any questions on the second row? Okay, third row starts with just a, what's this one called? It's just a quadratic. All right. The fancy ones are difference of squares, which this clearly is not. It's got 3 terms. Sum of cubes, difference of cubes, grouping, look-alike. This is none of those. This is just an old algebra 1 quadratic. So I'm just going to break it down with the shells. I know I have to do 7x and 1x. What are my signs going to be? For sure. And then I just know kind of, you got to get in the vibe with this problem to make that 1 in the middle, that -1 right here. I'll point to it for you. To make that -1, then you need to balance out the 8 and the 7, or the 8 and the, you want to put the 8 here is what I'm trying to say, and the 1 here. And then what happens is you get -8x plus 7x. Voila. Done. And there'll never be a can I go further with a quadratic. It's like 1 and done. So expect a few of those on the test. It's just, can you factor a quadratic? What's the trick to the next one? First off, maybe what is the next one? Do you know?
Same one as this one.
Yeah, it's the one, same as the one right above it, except you can't see it yet. Why? What's it got? Right. So it's not a lookalike yet. Like Kennedy said, it doesn't fit the mold of even half none. It's got, what is this? 5, 3, 1. So that's garbage. But what are we missing? Why can we not see it?
Well,
You've got to pull out a GCF. You've got to, or you'll never see the problem. That I do not want you to factor this problem. That is not your math problem. Your math problem is hidden underneath a layer of this. Why did I pull a negative? Because there's a negative up front. There's a negative at the beginning. You pull out a negative. And why did I pull out an X? Well, because I could, right? If they all have something to give, take it. And then what will expose itself is the actual math problem. What's left of negative X to the 5th? Positive X to the 4th. And what's left of plus 18X cubed? Minus 18X squared. And what's left of minus 80X? That white thing is the math problem that you have to do. The red was just the little bit of dressing that I sprinkled on top of it. It's out of the way. Now we do the math. It's a lookalike. We can see that it's a lookalike now. So we're going to leave our negative X out front, and then we're going to build our two shells, and we're going to half Z up the X to the 4th like this. What are my signs going to be? Minus, minus, and the numbers. Are we done?
no,
Yes.
wait.
These are both deliciously tempting. Like you're right at that, some of you are right at that iffy kind of stage where you're starting to recognize difference of squares. And these both look so good because they both have X squared minus, and you think, oh, I got it. But 8's not a square and 10's not a square. So this is done. What's up, Hugo? What's up?
I don't understand how the 18x and squared root of 3 by just pulling out an x.
It should be X squared.
Oh.
I'm very sorry. Yes. So,
Good observation.
yeah, no, you're right. I guess does that count as an incident?
Yes.
All right, then I guess today will stay at 0. You know, you're right. It should be a 2.
Yeah. Indeed, do.
Why what? In this class?
Yeah.
This?
Yeah.
Oh, it was Friday. I don't remember what I did. Oh, is that better, Hugo?
Yeah.
I'm sorry about my
Now I
mistake.
understand.
I'm so sorry. Yeah, you're sitting there going, what did I do wrong? No, of course it should have been a squared. That's my bad. So everyone recognized that the problem is over at that point in time? The 8 and the 10 ruin it, so we just put a box around that and we move on. If those 8s and 10s had been different, like a 9 or a 16 or a 4, then we could go further. We can't. And then the last problem in the 3rd row is a grouping. So we have 28x to the 3rd plus 24x squared minus 35x minus 30. It's grouping. We recognize it. We go 4 terms. I know what to do. Draw the wall. What's the GCF of the left side? 4x squared. What's left over? And then what do we do next? Drop your minus, like that. Pull out a 5, because I know that 35 and 30 can both be divided by 5, because I'm in high school. And then 7x, change the sign, 6. And you go, yeah, they match. Woohoo! So our first factor is the commonality factor, the 7x plus 6. Our second factor is built by the red parts. And what do we do from here? Nothing. We stop. And look, again, my teacher, God, it's like he's trying to trap me. This second one is so tempting, but what ruins it? Just the 5. That could have been 4x squared minus 1, I'd go further. 4x squared minus 9, I'd go further. But the 5 says, nope, I'm out. 5's not a square. So that's that. Any questions on the 3rd row? Last row. First problem right out of the gate. Houston, we have a problem. What is the problem?
Oh, they're out of order.
They're out of order, so let's fix that. So step 1 is let's just put everyone where they belong. So red term will go first, yellow or green term will go second, and yellow term will go third. So we're going to have negative x to the fourth plus 17x squared minus 72. Now what? We have a new problem, and it's that negative in the front. It's this guy right there. Boop, he's bad guy. So I'm going to pull out a negative like this. Boop. And then I'm going to rebuild the problem. For the first time, we're going to actually get to see the math problem that we're supposed to do. It's going to be positive x to the fourth, negative 17x squared, and positive 72. And there's the lookalike. It was there the whole time, just kind of hidden a little bit from us. So now that we recognize it for what it is, we're going to leave the negative out. We're going to build our two shells. We're going to divvy up the x to the fourth like this. What are my signs? Two negatives for sure, because they multiply to make a positive at the end. So they either both have to be positive or both be negative, and the middle tells us that they're both negative. And what are the numbers? 8 and 9. Lots of numbers multiply to make 72, but there's only two of them that will make this factoring problem work. And I am not finished. I agree. Which one is factorable?
Oh, no, no.
The 9. Right. And again, it's this second one right here. Just let it go. It's okay, Kason. Don't worry about it, okay? It's fine. So that one that I circled in red is intended to entice you. But again, the 8 ruins it for us because 8's not a square. So we're going to bring down the negative. We're going to bring down the dead factor, but then we are going to factor the difference of squares into just like that. If I'm any good at this job, if our relationship as a teacher and a student is even remotely solid, a problem like this should make you very happy. If you're not there yet, you should get there, because that's just a classic difference of squares. And we love these. They don't involve walls, and it's just boom, get in there and go. What's the square root of 16x squared? 4x. What's the square root of 9? And then we're done. We just have to build the pattern, square root plus square root times square root minus square root. Done. Those problems are just wonderful once you're willing to accept them for what they are. Factoring is hard. It's hard to practice and understand what's what, which is why it's imperative that you've been doing every problem to this point and that you continue to bust your butt for the next few days. What's the last problem? What is this? Yeah, it's just a quadratic trinomial. There's nothing. It's no difference of this, no sum of this, no grouping this, no lookalike this. It's just an annoying quadratic. And the trouble with these, once you get good at factoring, these will always be your least favorite. I don't mean to tell you your business, but inevitably that's what you'll get to, is everything else you can master with a process. This one is just, it's poopy. There's no way around it. So we go into it, and the issue here is that we don't know that that's true, because it could also be this. And to get even worse, it could also be like this. So if you don't like this, it's perfectly normal not to like. This should be the one you hate the most. What are the signs? Positive and negative, and you could sit around and try. Once you figure out structurally, like the templates and the signs, then it becomes a matter of just guess and check, guess and check, guess and check, guess. And sometimes you'll get it on the first try. Sometimes it'll take a while, but it winds up being this. When people say, I can't find it, I'm always like, it's there. Like, it doesn't make sense to me. Like, if you understand how to check your answers, because if you don't, that's a conversation you and I need to have, like, now, today, immediately. Because not knowing how to check if it's right, you're doomed. Because that's the essence of this is can I figure out if my answer is even correct? These make negative 45x. And these make positive 4x. And when you add those together, jackpot. So I didn't want to sit around and take up class time with taking your input on guesses and checks. I just wanted to show you that that's what it looks like when you're done, when you find it. So anything in the bottom row that you'd like to talk more about? There will be no more snapshots. That was it. That was my chance to look at you. I visited with a few of you and expressed the importance of you getting your act together and advocating for yourselves. The next snapshot, the next thing I get on my desk that will be for me to see how you're doing will be worth a lot of points. This quiz, if I recall correctly, is worth like 80 points. It's a great way to start the year. So, I mean, that's your next shot. But you do have today, tomorrow, Thursday. I mean, tons of flex times, tons of whatever you need to figure it out before quiz day. I would start making my page of notes today. And yes, I would start thinking about partitioning my page of notes. Something, I mean, I'm just making this up on the fly, but if you got a piece of paper, I might put like regular quadratics in the upper left. I might put like some difference of cubes, maybe somewhere up here, and then leave some space, and then maybe do difference of squares, maybe here, lookalikes, maybe here, grouping down here, and then that leaves you with some space down in the lower right where maybe you add some other things to remember, like primary among them. The thing that will separate the highest scores from the high but not highest scores, like A's to B's, A's to C's, is going to be these three letters right here. And that should go prominently, not annoyingly like that, because that's pretty intrusive on your page of notes, but that'll be the separator. Is, do you look at every problem and ask yourself, is there a GCF? Because without that first, you'll never get to see the math problem. You got no shot. So I'm going to hand out your practice quiz, and I'm going to kind of have you go through and look at it with me. We're going to have a quick talk, and then there's going to be a lot of work time today, tomorrow, maybe Thursday. So just plan on that. These take a while. First thing we want to do is go through each question on the practice quiz and look for a GCF. And I'm not going to do this with you when you take your quiz, but look at problem 1. Do you know what it is? Like, do you know what problem 1 even is?
Quadratic.
It's definitely not a grouping because it doesn't have 4 terms. It's a basic quadratic. We just can't see it yet because what is the GCF? We need to pull out a negative. Why are we pulling out a negative on number 1? Because it starts with a negative. What else can we pull out? A 2. And what else can we pull out? An X. So my job, and I'll just kind of get started. I'm not going to go through and do like tons of them, but I just want you to see that you will never, ever get to actually take the quiz if you think GCFs are just kind of optional. On number 1, I need to pull out a negative because it starts with a negative, and I need to pull out a 2 because they all have a 2. They're all divisible by 2. And I also need to pull out an X. And then what's left over after I pull that out? X squared minus 11x. And then what's after that? Minus 42. The white problem is the math problem. I'm just like a broken record, but I found in this profession that sometimes I have to say things 39 times. And on the 39th time, a kid will go, oh, I didn't know that. It's amazing what I do for a living. You need to pull out GCFs or you will never get to start the actual quiz. What about question number 2? What is it? It's got a GCF, doesn't it? So we look at it and go, I don't know what it is yet. I think I know what it is. Like I'm starting to see the pattern, but in problem number 2, I have to pull out X squared. And then I can see what I'm supposed to see. What's left of X to the 6th? X to the 4th. Remember, when we take out 2 X's, we have to drop the exponent by 2. We're like subtracting. What's left of the middle term? Yeah, and signs aren't changing or anything like that here because we didn't pull out a negative. And the back term, minus 36. And again, there is your math problem. Let's knock a few more out just so we can get you rolling here. I'm hoping you get the sincerity of the memo. There are GCFs all over the place. Third problem, what do you see? What is it? You'd be surprised, even after days and weeks of this, how many people would look at 3 and say it's a difference of cubes. That's infuriating for me. I don't want to give it a label yet because it's got a covering of GCF. There are people that would say, oh, those are cubes. Don't pass judgment until you get the stuff out. So we're going to pull out a 2. And we're going to pull out an X. And then we will reveal the actual math problem, which is what? Now, the white problem is a what? It's a difference of squares. You buying what I'm selling here? Okay. So that's going to be what you do for the next day, 2 days. Let's go through each problem, pull out the GCF, and then work the problem. But the GCF does not get thrown in the trash. It's not like something you're dividing by. It has to stay out front as you work your way down. So good luck. Let me know if you want some help. Come sit up here if you'd like to, or just raise your voice and tell me what you want to go over. I'd be happy to assist you. And remember that Flex is wide open. I doubt I have anyone signed up for today. I haven't checked, but I'm sure there's lots of spots. Lots of spots up. So the key to question number 4 is the massive GCF that you have to pull out. And again, you just cannot ever forget that the G stands for greatest. So you're not allowed to pull out just SOCF, like some old common factor. Like it has to be go big or go home. So in problem number 4, I see this, and this means nothing to me. If I said, what is this? Your job would be to say, I don't even know. It's just trash. What can I pull out of this? First off, what can I pull out of this? Pull a dang negative out. And then it's time to go and make your 4th grade teacher proud. What can the 6 and the 48 both be divided by? 6. And then how many X's can I get out of both? I can get out X to the 5. I got to think about what's the most I can grab from each of you guys at the same time. One guy says, I got 8. The other guy says, I got 5. You're like, I guess I'll settle for 5. So I pull out X to the 5th, and that concludes the GCF. And then what will show itself in these parentheses is the math problem that I wanted you to do. What's left of negative 6x to the 8th? X cubed. The negative 6 is gone. The x to the 8th has been dwindled down to just 3 lowly x's. What about the minus 48x to the 5th? Plus 8. And then the math problem is there. We just can't see it until we pull out the red thing. What is the white thing? Are you good from this point, Kane? Okay. If anyone else wants to press on, I will, but I would like your input. I just don't want to answer all the questions. So yes, what is, first off, we recognize that as a sum of cubes. What is my A value?
Oh, X plus.
It's because it's a sum of cubes. And whenever it's a sum of cubes, we have to find A and B so we can do short set, long set. What's A? And what's B? These are your tickets to success. Those things I've underlined in yellow are it. They are the building blocks for your short set and your long set. So I'm going to start by putting down my GCF. And then I'm going to do a short set, and I'm going to do a long set. What's my short set going to be? Nice job, Hugo. A plus B, x plus 2. What's my long set going to be? X squared
Plus two.
minus 2x
Plus
El gusto es mío. So I'm talking directly to Stesha, but if any of you want to come along for the ride for problem number 8, there's a very correct answer to the question I'm about to ask you, and I would like you all to get on board with it. What is this? The answer is I don't know yet. Because why? Because it's buried under a GCF. Underneath the layer of greatest common factorology is a problem that I want you to do. But when I ask you what it is, your answer should be not sure yet. I'll get back to you because I got to pull some stuff out, right? So what am I going to pull out? I'm going to pull out a negative and a 3 and an x. Because I know and you know that 48 and 27 can both be divided by 3. I know I got to get the negative, and I see that they both have at least one x to give. So I'm going to pull out my negative 3x, and that's going to leave me with 16x squared, change the sign 9. What is that white thing? What's it called? Now you can tell me what it is. What's his name? What is the white thing called? You can't hear me because people are moving around and packing things up. Is that what's happening? Is that what's, or take your hoodie off? That might help too. What is this thing called? It's got a name. It's called a difference of two squares. And we recognize it because it's something squared minus something squared. So when we factor it down, it factors into square root plus 3, square root plus square root times square root minus square root. You must recognize that as a difference of squares. No, they're different things. They will not work if you try to use exponents. One has a plus and one has a minus. They're not the same.
What?